Hello everyone, let us study benzoin condensation reaction. Moving on to benzoin condensation reaction. In the benzoin condensation reaction, this benzoin condensation was first reported in 1832 by Justus von Liebig and Friedrich Wöhler during their research on bitter almond oil. The catalytic version of the reaction involving cyanide. Here they are using the cyanide as a nucleophile, which will act as a best nucleophile and a good leaving group, and it is a weak base. Okay, so that they have used and they have developed by Nikolai Zinin in the late 1830s. The benzoin condensation. Moving on to definition of the benzoin condensation. Benzoin condensation is an addition reaction involving two aldehydes. The reaction generally occurs between the aromatic aldehydes or glyoxyls. The reaction produces an acetylene. In the classic application, benzaldehyde is converted into the benzoin. So in the benzoin condensation, here you are using two molecules of an aldehyde, resulting you in the benzoin in the presence of the KCN-azure base. Moving on to reaction, if you will see here in the reaction you are taking the two molecules of benzaldehyde and in presence of the cyanide, which is acting as a nucleophile. How the cyanide is formed, I will tell you in the mechanism step, and then resulting you in the benzoin-azure product. Mechanism. The reaction is catalyzed by the nucleophiles such as cyanides, I have said you earlier, or an N-heterocyclic carbon, usually thiazolium salts they will use. In the step 1, there are two steps in this mechanism. The first step is the attack of a nucleophile to an aldehyde. In the second step, it is the rearrangement of the intermediate, proton transferred, followed by the elimination, resulting in an benzoin product. Moving on to mechanism. Here if you will see the benzaldehyde, first you have to know how the cyanide ion comes. So here you are using the potassium cyanide. So if you will take the KCN, at that time if you will do the heterolytic cleavage, at that time what happens? And there is a dissociation of the reaction, resulting you in the K plus salt and the CN minus. Okay, so this CN minus will act as a nucleophile, and there is attack of that nucleophile to the carbonyl carbon of the benzaldehyde, which is an electrophilic carbon, okay, in nature. When that will go and attack, at that time what happens? The bond will shift, make a charge. Once you will get the structure number 1, okay, that is the formation of the oxide ion over there, and that time you will do the hydrolysis upon that. If you will add the hydrolysis is nothing but addition of the water. If you will add water, at that time what happens? The oxygen atom, which is having the lone pair of electrons, will go and abstract the proton, and there is a cleavage of the hydroxide ion, that is OH minus, okay, resulting you in the structure number 2. If you will have the structure number 2, which is the all form, that is the alcohol form, if you will result in the structure number 2, and there is a hydroxide ion which has been cleaved out in the structure 1, and there that hydroxide ion, again it will go and attack the lone pair of electrons of the hydroxide ion, will go and abstract the proton, and there is a shifting of the bond over there. When this will shift, at that time what happens? The cyanide, that is C triple bond N, this one bond will shift and resulting you in the N minus ion. Okay, that is your nitrite enolate ion. And again in the next step, what you are doing in the reaction, we have said there is two molecules of benzaldehyde which you are using for the formation of the benzoin. Okay, one molecule we have used already for the nitrile enolate formation, and then now second molecule of the benzaldehyde comes into picture. This minus charge or the lone pair of electrons which is present in the nitrogen atom will move and it will generate one bond. This bond will go and attack the carbon-carbon double bond which is present in the nitrile enolate, that will act as a nucleophilic carbon atom. Okay, that nucleophilic carbon atom will go and attack to the electrophilic carbon atom, which is electrophilic carbonyl carbon atom of the benzaldehyde. When it goes and attacks, at that time the bond will shift and make a charge again over there. Okay, at that time you will get again this type of structure, which is your structure structure number 4, and then you will get the oxide ion, right? So once you will get the oxide ion, again you are doing the hydrolysis reaction. Upon addition of the water, the oxygen again will abstract the proton. The lone pair of electrons from the oxygen atom will abstract the proton, and there is a cleavage of the hydroxide ion in this structure, and then the hydroxide ion will get cleaved out and resulting you in the 2-ols form, that is the enols form. And then this hydroxide ion, again it will abstract the proton from here, generating you an oxide again in the structure number 5, and then resulting you in the structure number 6. When this will abstract the proton, this bond will shift, make a charge, you will get this one. And then if you will see in the structure number 6, this lone pair of electron will shift, make a bond, and there is a cleavage of the cyano groups which will act as a good leaving group. Okay, when the cyanide gets cleaved out, resulting you in the benzoin as your product. Thank you.